All right, so last day we talked about we talked about matter, and we talked about how everything is made up of matter, and matter is something that has weight or mass and takes up space. So what we're going to do today is we're going to look at the classification of matter. Now, so matter is classified by its physical and chemical properties. Physical properties, what does it look like? Chemical properties, what does it act like? So we had started to talk about this in class before March break. If we're talking about paper, a piece of paper, physically it's a solid, physically it's white, physically it's opaque, you can't see through it, physically it's soft, and so that's what it looks like. Chemicals, what does it act like? Well, we can say it's combustible. If it warms up enough, it will burst into flames. So it's combustible. So we can talk about what it looks like, and chemical, what does it act like? Now, matter that is not a mixture is a pure substance. So if we go to the periodic table, that's not what I want, that's what I want. This is the periodic table. These are all the known substances, or these are all the known basic substances. We have lithium and beryllium and sodium and magnesium and potassium and calcium. These are the Legos of the world, and then we could put these things together as well. If we put hydrogen and oxygen together, well, two hydrogens and one oxygen, we get water. If we put sodium and chlorine together, we get table salt. So if we put these things together, we get other substances as well. So if it's pure, such as gold or sodium, then it's not a mixture. Sometimes we can mix things together. So a pure substance is made up of only one type of matter. Now, water would be a pure substance. If you had a glass with only water in it, only H2Os, that's pure water. The water that you get out of your tap is not pure water because what's coming out of your tap is H2Os, water, but there's also a little bit of sodium in there. There's a little bit of chlorine in there to make sure that there's no algae. There is some fluoride in there that's been added in so your teeth stay strong. There's different minerals, so it's not pure. You may have a pure copper pipe with nothing but copper in it. That would be pure. Likewise, aluminum. If all that is in the piece of metal that you have is aluminum, then it's pure aluminum. Now, two main types of pure substances. So we have, I'll start with the second one first, elements. That comes from your periodic table. If you only have hydrogen, it's pure and it's elemental. If you only have sodium, it's pure and it's elemental. If you have water and only water, then it's pure, but it is a compound because it's made up of H's and O's. So if you have a bowl of table salt, nothing else, just table salt, it would be a compound because that compound, table salt, is made up of sodium and chlorine. So if it's just gold, or if it's just something on the periodic table, it would be an elemental pure substance. And if you have something like just water or just table salt, it's pure, but it's a compound because it's made up of more than one element type. Hopefully you get that. Therefore, compounds must contain more than one element type. And so we have this chart here. So everything's made up of matter. On the pure substances side, if we have pure gold or pure sodium or pure chlorine or pure neon, those are elements on the periodic table. Over here, if we have a bowl of just salt or a cup of just water or a beaker full of just carbon dioxide, it's pure because that's the only thing in there, but it's a compound because it's made up of more than one element. Now on the other side, we have mixtures, and this is where we mix two things together. And we have two different types of mixtures, homogeneous and heterogeneous. Homogeneous, you can only see one thing. Heterogeneous, you can see more than one thing. So if I put salt into water and I stirred it up, and you cannot see the salt anymore, it's dissolved, that would be a homogeneous mixture. In that cup, there is water molecules and salt molecules. So it's not pure anymore. It's got more than one thing in it. But you can only see one thing, so it's homogeneous. Heterogeneous means you can see more than one thing. If I make a salad, you can see all the different things. You can see the tomatoes, you can see the cucumbers. A granola bar is a great example. You can see the nuts, you can see the granola, you can see the raisins, you can see whatever. So that's heterogeneous, where you can see the different parts. So that's what this is talking about. Pure substances can be divided into elements or compounds, and mixtures could be homogeneous, you cannot see the different parts, or heterogeneous, you can see the different parts. Homogeneous has another name for it. We call that a solution. So when we mix up the salt and you don't see it anymore, that is a salt water solution. And for heterogeneous, we call those mechanical mixtures, and that's where you can see the different parts. Now, a special name for when you mix metals together is called an alloy. So sometimes we mix metals together to make them stronger, to make them rust resistant. And so when we're mixing metals, we don't call that a heterogeneous or a homogeneous mixture. We call it an alloy. All right. On the periodic table. You can't see on this periodic table, but right here, if I go right through here, it forms a staircase. And I don't know if I can see a periodic table here quickly with a staircase in it. This one has one. So you can see right here, there's this gray line here. And it is a staircase. Everything over here on the left side, these are all metals. Everything on the other side of the staircase, we call these, or these are, we don't call them, they are non-metals. So metals and non-metals. The only exception is hydrogen here. It's a non-metal, but it has to be over there for another reason. We'll get to that another day. But other than that, this staircase, everything to the left of it is a metal. Everything to the right of it is a non-metal. Now, so what are metals and non-metals? So metals are elements that have these physical properties. They are almost always shiny, so they have luster. They are malleable. You can hammer them or pound them flat. Maybe not you, but with a press, you could do that. Ductility. You can pull it out into a long wire. So maybe you can't grab onto a piece of brass and stretch it out, but a machine definitely could. They are good conductors of heat and electricity. And at room temperature, with the exception of mercury, they are all solids. Mercury at room temperature is a liquid, but all the rest are solids. Non-metals, they are dull. Quite often, non-metals come in a powdery form, and they are dull. They are not shiny. They are not malleable or ductile. So I know this is not. Think of wood. You can't pound a piece of wood; it would just shatter. You cannot stretch a piece of wood out. So those are examples there. They are often poor conductors of heat or electricity, or they will not conduct it at all. And at room temperature, you can find them either in solid, liquid, or gas form. So those are our metals: shiny, solid, malleable, ductile, and great conductors of heat or electricity. And non-metals, these are things that are dull, you're not malleable, not ductile, poor conductors, and they can be found in all three states at room temperature.